So on Friday, we talked about friction, and as we pushed on the box harder and harder and harder and harder, friction increased. This was static friction. At some point it breaks away. So this is your maximum static friction. And then once it starts slipping, that's kinetic friction. Okay. So static friction, static friction, static friction, maximum static friction, and then kinetic once it starts slipping. Get that? Okay. We have one equation that describes friction. That is the coefficient times the normal force. Coefficient talks about how rough the surface is. Normal force, how hard the surface is pushing two things together. We can modify that for kinetic or maximum static friction. Okay, so recap of Friday. Give that one a shot. Talk to your neighbor. Correct answer is okay. A would be correct if it said has the potential to exert more force. But if it actually exerted more force, that'd be kind of weird. Boy, you better push that hard, because if you don't, it's gonna come back and get you. Does that make sense? Like if there's more friction than what you're pushing, it's gonna accelerate towards you. Does that'd be weird? That'd be like troublesome. That would just okay. Has potential, but the correct answer is B. Okay. If I'm pushing with 100, it pushes back with 100. If I'm pushing with 200, it pushes back with 200. Okay. Talk to your neighbor. Okay. Heard an overwhelming C. Because kinetic friction is less than your maximum static friction. Good with that? It's motion, its inertia is in motion, it wants to continue in motion. Okay. Talk to your neighbor. Correct answer is C. Looking at our equation for kinetic friction, it is dependent upon how rough the surfaces are, and the normal force between those has nothing to do with speed. Once it's slipping, regardless of how fast it's slipping, kinetic friction is going to be a set value. You okay with that? All right. Set this one up. Free body diagram, sum of the forces in the x and y direction. Go. Okay, I'm going to make the positive x direction the way it's moving. How do we do? It's not illegal to make the other way positive, but it just gets really sticky mathematically. So suggest making the way it's moving positive. There is no applied force. He's not swimming on the ground. He's just sliding. He's already jumped. Okay. What type of friction is it? Is it going to be static or kinetic? Slipping, sliding, kinetic. So make this small modification there with the subscript. Okay. All right. Now we're starting ready to look at stuff. What am I looking for overall? Like ultimately, what am I going for? Yeah, Ben. Acceleration. Where do I find acceleration?
You need to use one of those, like the kinetic equation.
Yeah, the kinematic equation. If I had motion, like distance, time, some velocity, I could pull that off. But kind of stuck in that regard because I don't have anything but the guy's mass and a coefficient.
I don't know. I'm seeing this one. So then for the force, you can, for the normal force, you can find it out.
Okay, yeah. Okay. Yes, yes. Here's all I was going for. Find it right there. And then, in order to find this, here's our shopping list. I need to figure out mass. Do I know mass? Yep, 75 kilograms. And do I have friction? Can I plug in 0.5 here? That is the coefficient of friction. The only thing I can, so if I'm given the coefficient, the only equation that has coefficient in here is that one. Okay. Oops. So I need to, so I've got 0.5, but I need normal force. Where are we going to find normal force? So that's equal to the force of gravity. So can I say normal force is equal to 75? What can I do to figure out the force of gravity? Multiply by 9.8. Force of gravity is equal to 75 kilograms times 9.8. So I find force of gravity to be equal to, what is it, 735, is that correct? Okay, 735 newtons. Take that, stick that in here. So normal force is also equal to 735 newtons. What can I do with that? Ben? Use that there. 735. So kinetic friction is equal to 367.5. What can I do with that? Whew! Acceleration is equal to craziness. Bless you. All right, so a lot of little steps. Nothing crazy taxing math-wise in the little steps, but there's a lot of little steps. Okay, please set it up. Please organize your work. Okay. Any questions? Any points of confusion? Any like what? What? Huh? Any of that? Like you don't even have to come up with a good question. Just kind of point to the general area and go, okay, set this one up. All right, just so we're on the same page here. Step one, and do the sum of the forces in the x and y direction. Okay. Here, what type of friction is this? When it says, what is the minimum force you need to push the couch starts moving, those are phrases that scream maximum static friction. Okay? And because of that, we're going to say it has not yet begun to slip or slide. So we're going to say some of the forces are equal to 0. Does that make sense why I'm doing that? It has not yet, is just about to slip or slide. Okay, so how do we do? Oh, I'm still not done yet. How do we do? Grade yourself out of 5 on the setup. Doesn't make sense. Are there questions, points of confusion? If you don't get the setup right, you have no hope of getting the right answer. Okay, so the setup is like kind of like vital. That's why I've spent so much time on the setup. Okay. All right. What am I looking for? When can I be done with this problem? When I find this class goes way faster when you guys actually like throw some stuff at me. Beautiful question. So here's the memorized response. Whatever angle this is, that is always the same angle if you make the x-axis parallel to the ramp between the force of gravity and the new y-axis. Kind of the memorized thing. A lot of times people get that confused between this and this. That's a typical, okay? If this is a shallow or really shallow angle or a really steep angle, you can kind of look at this if you draw it to scale. Like that's a smaller angle than that, and that's probably my 20. Welcome. Nora.
You can find the force of gravity in the X direction.
Okay. Before I do that, yes, I'm looking for applied force. Okay. So applied force you find in the X direction. So this is my shopping list. I need to find this, and then I'll have that. Okay. So to find FGX, can I stick in 100 right here?
Wait, what?
Caroline.
How do you know that you're looking for a force?
Great question. What is the minimum force that you need to push? So you're the one doing applied force. So I'm solving for applied force. Does that make sense?
Yeah.
Okay. Okay. So if I can't stick 100 there, can I stick 100 right here? So what can I do with this 100? I mean, that seems. Nora. I want to take this and multiply by 9.8 to find my force of gravity, to find my weight. So I've got 100 times 9.8. So I find that to be equal to 980 newtons. It's my force of gravity. Can I take that? Oh, can I take 980 and stick it in for this? Come on. Why not? So much work. So tell your neighbor what side of the triangle this is relative to the 20 degrees. Is it opposite? Is it adjacent? Is it hypotenuse? The red side. What is that? Tell your neighbor. Tell your neighbor, or tell me what trig function am I going to use to find that? Sine. So I'm going to say sine of 20 is equal to FGX over 980. And FGX is equal to, talk to me, what do you got? 338, 35, I like it. 335 newtons. Can I stick 335 newtons in for this? Yes. Whew, finally. Check that off the shopping list. All right. Maximum static friction. All right. 0.4 says static friction, right? Can I stick 0.4 right there? No. That is also a popular pitfall. What is 0.4? Coefficient. So anytime you see coefficient, you need to write this equation. Okay, I'm going to write that with maximum static friction. So am I going to use 0.4 or 0.3? We're saying it's just about to start slipping and sliding. That is 0.3 is a distractor. So I got 0.4 times normal force. Where do I find normal force? Gotta be kidding me. Who makes you do these things? Normal force. That's not even equal to something easy either. What? Tell me what I'm going to use. What trig function to find FGY? Cosine. So cosine 20 is equal to FGY over 980. I find FGY equal to, what is it? 921. 921 newtons. Whew. So that's there. So I find normal force is also equal to 921 newtons. What can I do with that? Equals 921 newtons, which gives me maximum static friction, which is equal to 368 newtons. And then what can I do with that? Whew. Tell me I'm almost done. So I've got applied force minus six, I'm sorry, 368 minus 335 applied force is equal to 703, right? Boom. Lots of steps. Not difficult steps, but lots of them. Set it up, organize your work. This is the most involved types of problems that you're gonna have the whole year. Like this is it. This is like Everest. So get through this. Complicated setup wise, gets easier. Okay, good with that. Okay. Questions, any points of confusion before this goes away? You don't even have to ask a good question. It just needs to be like a huh? Anything. Please. Kylie.
Okay, so whenever finding the max friction thing,
Uh-huh.
will it always be connected with the static friction?
Yes. Yes, good question. So here's one equation. These are always connected. The other equation corresponds to kinetic friction. So you're never going to mix and match these. This is always going to kinetic, and kinetic's going to be linked. Static and maximum static is always going to be linked. Okay. Other questions? Great question. Other questions? Points of confusion? Like, just throw it out there. It doesn't have to be pretty. It just needs to be like, it's a lot of work to erase. Really helpful if we brought out any questions before we go with it. Okay, gone. Next question. Tell your neighbor. Correct answer is? Correct answer is C. Once it starts slipping, It drops from maximum static to kinetic friction, which is less than maximum static friction. So there's less friction opposing the force of gravity in the x direction. Therefore, it speeds up. Okay. Bless you. Bless you.